So like we've been doing, we are going to break up this lesson into two pieces. So this is part 1 of 18.1, classifying polygons. So as you can see, there's a lot of vocabulary in this. So we will do a little bit at a time to make sure we have a good understanding. We are going to start with identifying open and closed plane figures. Now, if we look at group A, all of these have an opening in the figures. So these are considered open plane figures. And then if we look at B, these are closed plane figures because there's no entrance inside of this figure. So plane figures are just flat figures. They have a length and they have a width and they may be open or closed. So all of these count as a plane figure. These are just open and these are closed. I'm going to do a little practice to decide whether these figures are open or closed plane figures. So as discussed on the last slide, these are all considered plane figures. We were just deciding if they are open and closed. Now, if we look at this one and we follow the lines, it does not connect all the way. So this is considered an open figure. Now the next one, if we follow the lines, they all connect. So this is closed. And then our final one, if we look at that and follow the lines, it does not connect. So this is considered open. So identifying polygons. So closed plane figures can be put into two groups now. We have group C here, and then we have group D here. Take a moment to think about how they are different. Look at the different types of lines that we're seeing. Now, if we look back at group C, these are formed by line segments. These are straight lines. So group C is considered a polygon. Group D is not. Now, group D is not because they are not line segments. If you look at the shapes, they are not straight lines. So a polygon is a closed plane figure formed by 3 or more line segments. 2 line segments cannot meet to form a closed figure. So 2 line segments cannot form a polygon. So that's why it's 3 or more line segments. So take a look again and think about why these are considered polygons and why these are not. So we're going to do a little practice here about polygons. So a polygon has straight sides or edges. 2 edges meet at each vertex. That is the corners that we talked about before. It has no gaps or spaces and has no leftover lines or intersecting lines. Those are lines that will cross over each other. So we're going to do a little game here. Is it a polygon? So I'm going to show you a shape and give you a couple seconds to think and decide whether you think it is a polygon or not based on what we just learned. So think about, is this a polygon? Nope, it is not, because it does not have straight sides or edges. It has those rounded edges there. The next one, is this a polygon? You have 5 seconds. Yes, it is a polygon because it has straight sides, 2 edges meet at each vertex. These are our vertex, those corners. And there are no gaps or spaces, and there are no leftover lines. All right, the next one, you have 5 seconds. No, this is not a polygon because it does not have straight sides or edges. All right, you have 5 seconds to think about if this is a polygon or not. Yes, so although it's a funky looking shape, it does have all straight sides. The 2 edges meet at each vertex, which is right here. There's no gaps, no spaces, and no leftover lines. So although this is a crazy looking figure, it is considered a polygon. And take your 5 seconds. Yes, it is a polygon. It has straight sides, 2 edges meet at each vertex, and there are no gaps or spaces and no leftover lines. We'll do one more. So think about if this is a polygon. Nope, does not have those straight lines that we need. So we are going to be thinking about which of these figures are polygons. So if we look at figure A, yes, it has straight lines, but it is open, so it is not a polygon. If we look at B, yes, it is closed, but it is not straight lines, so this is not a polygon. Figure C has all straight lines. It is closed. It doesn't have any leftover lines. The 2 lines attach at the corners and vertexes. So figure C is considered a polygon. Now D, straight lines, but it is not closed, so that is not a polygon. Figure E, straight lines, closed figure. The corners come together to create that vertex of the 2 lines. So yes, E is considered a polygon. And then if we look at our final figure, F, it has straight lines. The lines come together to create that vertex or that corner. No intersecting lines, so that one is considered a polygon. Hopefully you're getting the hang of this by now. So this is an optional activity that you can try if you have the supplies at home. It only takes some craft sticks to practice making different polygons. Now we are going to start looking at special polygons and their names. So now we were just deciding whether these shapes were considered a polygon or not. But now, once you decide it is considered a polygon, these polygons have some special names. So they are classified by the number of sides that they have. And these are some of our examples. So this 3-sided figure, which I think we all know is a triangle. This 4-sided figure is a rectangle. And we should remember this one because we know a square has 4 equal sides, so that's why these 2 are different. Rectangles have 2 sets of equal sides. Then we have a pentagon, which is a 5-sided shape, a hexagon that is a 6-sided shape, and then an octagon, which is an 8-sided shape. So thinking about why these are all polygons. They're closed figures, they have straight lines, they have these corners that create that vertex. There's no extra lines, and they all have 3 or more line segments. Now, in a polygon, each line segment is called a side. 2 sides of a polygon meet at a point called the vertex, okay? Now, this is a very important example to pay attention to, okay? So we talked about the angles in your quick check yesterday. So the angle is this area where those 2 lines meet. The vertex, though, is like that corner, okay? So once you find that corner piece right there, that is our vertex. Then all of these are our sides, and then they named the shape as a triangle. So a corner is a vertex. Vertices is the plural form of vertex. So when you're saying it has 3 vertices on this shape, the 1, 2, 3, that's how you would say that. So that's one of our irregular plural nouns. All right, so for number 5, we are looking to identify the angles and label the parts of this pentagon. So our angles are where those two line segments meet. So here is one angle, 2, 3, 4, and 5. Now, if we look at where these are pointing to, this is pointing right directly at that corner right here. So this is pointing to a vertex. And now this one is pointing to the line segment, and the line segments we call sides. So that is pointing to a side. This is pointing to a vertex. Now they want us to count the number of vertices, count the number of sides, and count the number of angles. So if we scroll back up, count the number of vertices. So we had 1 there, 2, 3, 4, 5. So we have 5 vertices. Number of sides, we have 1, 2, 3, 4, 5. So 5 sides. And then our number of angles, we can go back and count those. There was 1, 2, 3, 4, 5. So I hope by now that you are noticing that a 5-sided figure has 5 vertices, 5 sides, and 5 angles. So we're going to do a little true and false practice, just thinking about some of the shapes that we looked at. So an octagon, based on what we just did here, it has 8 sides and 8 angles. So try and envision an octagon, and we know it has 8 sides, and if we think about that shape, it does also have 8 angles. So this is true. Number 10, a hexagon has 7 vertices and 6 sides. Now, do we think based on what we did before, would that make sense for it to have 7 vertices but only 6 sides? It would not, so this is false. Number 11, a square and a rectangle have 4 vertices and 4 angles each. Now both of these are 4-sided figures, so this would be true. If it's 4-sided figure, it's going to have 4 vertices and 4 angles. Now, this is one that often people get tricked with as we continue. So all polygons have 4 sides. That is false. Now there are a lot of 4-sided figures that we will look at, but there are other shapes that are considered polygons besides just the 4-sided figures. This piece of this that we're going to talk about is quadrilaterals. So quadrilaterals are polygons with 4 sides and 4 angles. So if we take a look at these shapes, all of them have 4 sides. They're all closed figures, so they're polygons, but they would be classified as a quadrilateral. Now, quadrilaterals you will see all over the place, especially if you're thinking back to your scavenger hunt that you did yesterday. These may be some of the things that you saw around your house. So the outline of the door is a quadrilateral because it has 4 sides. The outline of a notebook is a quadrilateral, and the outlines of a television, kite, and whiteboard are quadrilaterals too. So we're going to practice choosing the quadrilaterals. So we're just paying attention to if it has 4 sides. This one has 1, 2, 3, 4. So yes, A is a quadrilateral. B also has 4 sides, so this counts as a quadrilateral. Now C is not a polygon because it does not have straight lines. D is only 3-sided, so no. E has way too many sides, so it's not a quadrilateral. Neither is F, G, but H also is. It has those 4 sides. So we're going to do some true and false here. So the outline of a ruler is a quadrilateral. That is true. A ruler has 4 sides. The outline of a bottle cap is quadrilateral. False. Bottle caps are round. That would not work. The outline of a postcard is a quadrilateral. True. And the outline of an envelope is a quadrilateral. That is also true. So this is where we are going to stop for part 1 of 18.1. You are doing your workbook pages 195 through 198 once you finish. And please post a picture on Seesaw and put it into the math folder.